In our next lesson, we'll go ahead and discuss triangle inequalities and the sides that are possible in making a triangle. Here we have a picture of the Tower Bridge in London. How long must each side of this drawbridge be so that it spans the River Thames when it comes down? So you kind of want to think about this as a triangle. Here's your base, and then these are the possible other sides to your triangle. And think about when it comes down and our pieces meet up, do we want those drawbridge pieces to be shorter when we add them up than the third side? Would that make a safe crossing for a bridge? Or do we need them to be longer so that when they fall down and come together, they overlap? Triangles are similar. The sum of the lengths can't be less than that distance across the water. Otherwise, this would not be safe. Here is a triangle. You can use a protractor and measure the side lengths and angles of the triangle. Once you've done that, you can then go ahead and list the sides from least to greatest order. So I don't know these lengths, but if I look at them, I can kind of get an idea. So if we were to measure with the protractor, we'll be able to see kind of what those lengths and angle measures are. If I want to list the sides in least to greatest, I can see that side AB is my shortest side. BC would come next. And then AC would be my longest side. When I look at my angles, I need to look at the angle measures. Angle C is my shortest angle, then angle A, and then angle B. We should notice that our shortest side is directly across from our smallest angle. Our largest side is directly across from our largest angle. And our medium side length is across from the middle angle measure. We have a couple of theorems. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So for example, if we know that AB is 8 and BC is 5, AB is greater than BC. Therefore, the measure of angle C will be greater than the measure of angle A, because angle C is across from the longer of the two sides. It'll be bigger than angle A, which is across from the smaller of the two sides. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. And the converse of this is the first theorem here. So we have the measure of angle A is 50. Side across from that, BC, will be greater than the side across from our angle that's 30, AB. In our example, what is the measure of angle A? So in order to find that, I'm going to go ahead and add up my three sides, and they should add up to 80. So right now when I add up angle B and C, I have 144. When I subtract that from 180, angle A will be 36 degrees. Now that I know angle A, I should be able to decide what the longest side is. It's going to be across from my largest angle, so that's going to be side AC. The shortest side is across from my shortest angle. That'll be side AB. The middle length side will be across from the middle angle measure, and that will be BC. It says write an inequality that describes the order of the lengths of the sides. So I'm going to start with my least side, which is AB. AB is less than BC, which is less than AC. We can only determine order by angle measures or side lengths. We cannot calculate the exact angle measures or the side lengths. So even if we don't know what these lengths are of our triangle, we just know the order of the lengths. Small to large, large to small. List the sides or angles in order from shortest to longest in the following triangles. So because I'm giving you the side lengths, I'm asking you to give me the angles that go along with that. So again, 11 is the shortest side. It's across from angle E. So angle E is less than angle D, which is less than angle F. In letter B, I'm giving you the angles, so now I'm asking you for the sides. So angle C is the smallest, so that makes AB less than AC, which is less than BC. Now we have angle 1, 2, and 3. So these are not their measurements. These are just the angle names. So I have side lengths of x, x plus 2, and x plus 4. So right away I know that x is going to be the shortest side. That's across from angle 2. That's less than. X plus 2 is my next longest side length. That's across from angle 1. And that's going to be less than my angle that is across from x plus 4, which is angle 3. How do we know which of these pieces can be used to build a triangle? We have a triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So for example, AB plus BC, two side lengths, has to be greater than the length of the third side. If I said AC plus BC, it would have to be greater than AB. And AB plus AC should be greater than BC. If you have that inequality statements correct, then you have possible side lengths of a triangle. Is it possible to have a triangle with sides 5, 6, and 12? Well, let's see. If I have 5 plus 6, it should be greater than 12. If I add 5 plus 12, it should be greater than 6. If I add 6 plus 12, it should be greater than 5. So we'll go ahead and check. 5 plus 6 is 11. Is that greater than 12? No. 5 plus 12 is 17. That's greater than 6. 6 and 12 is 18. That's greater than 5. But it did not work for this first inequality. So is it possible to have a triangle with those side lengths? The answer is no. A triangle has one side of a length of 12 and another a length of 8. Find the possible values of x if x is the length of the third side. So here I have a diagram. I have x, 12, and 8 as my side lengths. If I take x with the smallest side, given x plus 8, it should be greater than 12. Solving this inequality, I'd be subtracting 8 on both sides. My x value has to be greater than 4. Let's say x is my largest side. And then I have this length of 12 and 8. I take my two sides and add them together. That has to be less than x. So 20 is greater than x, or x is less than 20. When I take a look at that, I just write my inequality statement. 4 has to be less than x, has to be less than 20. So my value of x is any number greater than 4, but less than 20. Those are the possible side lengths. I don't need to list them. I can leave it as an inequality like this. Go ahead and pause the video and you try. So we're adding up our two sides to see if they're greater than the third. It does work for example A. It does not work for example B or C. Specifically on C, if I take 3 plus 6, it should be greater than 9, and it's not. It's exactly equal to 9, so that statement is not true. Describe the lengths of the third side of the triangle given the lengths of the other two sides. So if I take my two sides and add them up, I'm going to get the greatest value in my inequality. If I take my two sides and I subtract and take the absolute value, that's going to be the least number in my inequality. So 3 plus 4 is 7. Here it is. 3 minus 4 is -1. Absolute value is 1. These are the side lengths that my x value needs to be in between. Same thing with this. I can add them, and I'll get 30. I can subtract them, and I'll get 6. So my inequality is 6 is less than x is less than 30. We also have something called the hinge theorem and its converse. If two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. So in our picture, we have two sets of congruent sides. The included angle is that angle that is created by the congruent sides. So my angle here for V is included. It's in between side VW and side VX. In my second picture, I still have those two sets of congruent sides, and angle 4 is that angle that is included. When I look at my drawing, angle V is 88 degrees. That is bigger than angle R, which is 35. That tells me that the side, WX, is going to be longer than the side, ST, because the angle it was opposite of was bigger than this one. The converse is also true. Let's say we are talking about two sets of congruent sides, and I give you the third side of each triangle. The third side of our first triangle is larger than the third side of our second triangle. Therefore, the angle C will be larger than the angle F. Complete the following statements with less than, greater than, or equal to. We have segment AC compared to EG. Here is AC, and here's EG. So I'm looking at the two side lengths and the included angle. My side lengths here are 16 and 14 with an included angle of 32. And again, I have 16 and 14 with an included angle of 32. Because the side lengths are congruent and my angles happen to be congruent, that leads me to believe that AC will be equal to EG. AB compared to FG. AB is this length. FG is this one. Now we do have two sets of congruent sides, but now we have to look at the included angles. This angle is 100, whereas this one is 116. The side opposite the larger of the two angles will be the larger of the two sides. So FG is going to be larger than AB. So AB is less than FG. If BE is 12 and EG is 8, what's the comparison between the measure of BDE and EDG? Well, I do have my two sets of congruent sides. Opposite angle D is 12. Opposite of angle EDG, yep, this one here is 32. The side opposite that is 8. That means that this angle here, EDG, is going to be smaller than this angle, BDE. So BDE is greater. Looking at our last example for this one, if EG is 8 and CF is 8, what do we know about these angles here? I'm looking at my side lengths. I've got 14 and 16. 14 and 16, my included angles are both opposite side 8, so they would have to be equal to each other. You have some examples to draw. Go ahead and pause the video. As we take a look at our examples, complete our statements with less than, greater than, or equal to. AB compared to DE. AB will be less than DE because our included angle was smaller. Our next one, we have two sets of congruent sides and the included angle is the same. Therefore, FG will be equal to LM in measure. In our next example, we have angle 1 compared to angle 2. We have a right angle here. We have markings of congruent sides. And we have the side opposite that. Angle 2 is opposite side 8. Angle 1 is opposite side 7. Therefore, angle 1 will be less than angle 2. In example D, we have the same side here. So we have same side congruence using that reflexive property. And we have our second set of sides marked congruent. And we have them opposite a given side length, both of which are 6. Therefore, angle 1 will equal the measure of angle 2. As we look at example E, MS is this segment. It is across from angle 95, and LS is across from angle 98. 98 is bigger than 95, therefore MS will be smaller or less than LS. And in our last example, for this, we have angle 1, opposite side 9, angle 2, opposite side 8. Therefore, angle 1 will be greater than the measure of angle 2. As we look at letter G, it's asking us to match the conclusion on the right with the given information on the left. We have AB equal to BC, and the measure of angle 1 is greater than the measure of angle 2. So they're not congruent. 1 is greater than 2. So if 1 is greater than 2, the side opposite of it should be greater than this side that's opposite it. So we can say AE is greater than EC. That's example D. So that one's done. When I look at my next set of information, we have AE. AE is greater than, so this segment is greater than EC. AD equals CD, so this congruent to that. Let's see what we know. We're talking about, angle 7 and angle 8, sides opposite that. So this side, this angle, and this angle. Angle 7 should be greater than angle 8. And that's what we have in example A. So that one's done. Looking at our next image, the measure of angle 9 is greater than the measure of angle 10. We know that BE is equal to ED. They obviously share this side in common, so we're referring to this side over here and this side here. So we said that we said measure of angle 9 was less than the measure of angle 10. Therefore, that side, AB, should be less than this side, AD. So AD is greater than AB. That's option B. And our last example, AB equals BC. AB equals BC. They're congruent sides. AD equals CD. AD equals CD. So we're referring to the measure of 3 plus 4 and the measure of 5 plus 6. If our sides are congruent, our included angles would then need to be congruent, or that sum. So that's option C.